Welcome back, geometry students. We're going to finish up our unit on rigid motions. And how we're going to do that? With the lesson on rotations. Rotations are the turns, the turning. And so what we're going to do in this lesson is read rotations. We're going to draw rotation images and then work about rotations in the coordinate plane. And that's kind of how we're going to start right now. We're going to start with rotations in the coordinate plane. Now here is a little activity that you find in the online text about the Solve It section, and we're going to talk about what's going on. So when we read this carefully, we get an ordered pair in the plane, and it's rotated counterclockwise. Now make sure you know what counterclockwise means. It goes this way, and we're rotating it about the origin. Like, what does that word about mean? And we'll talk more about that as we go through. And so we're rotating this, this point. We're going to rotate it 90 degrees, then 180 degrees, then 270 degrees. So we're going to rotate it 90 degrees, then 180 degrees, and then 270 degrees, which is 180 plus 90, by the way. And we're going to figure out, well, what's going on with the new coordinates and how does that relate to the original coordinate. So what was the original coordinate? Where we're starting at 3, 2. And if you remember, coordinates are read as the x-coordinate and the y-coordinate. So we have to recall that, okay, make sure we understand that, and we'll figure out what's going on. So we start our original thing, and we're going to rotate it 90 degrees counterclockwise. See that right angle? 90 degrees counterclockwise, we end up here. Now where in the world is here? So here happens to be at -2 in the x, +3 in the y. So we have -2 in the x, +3 in the y, and what we're going to do is figure out how does this relate to the original ordered pair. How does it relate to the original position? Funny enough, interesting things are happening. Look at the relationship between the two coordinates, right? The two sets of coordinates. This x-coordinate here, that 3, seems to be the new y-coordinate. So like this new y-coordinate is the old x-coordinate, right? So funny, the new y-coordinate is the old x-coordinate. And that's what that looks like. The new y is the old x, right? So what's the deal with the new x, right? What's the new x-coordinate? It's the opposite of the old y-coordinate. So our y-coordinate's 2. The opposite of 2 is -2. So the new x is the old y. So the new x is the opposite of the old y. Okay, so the opposite of the old y. And that's kind of the relationship. So what's happening here after a 90-degree rotation from an xy ordered pair is now the opposite of y and then the x. Funny how that works. Let's continue. It'll probably make more sense by the time I finish. So what's going on with a 180-degree rotation? We start from the original thing, and we rotate it 180 degrees on a straight line. So notice there's another 90-degree angle there. We end up here. Well, where is here? Where is here? It's at -3, -2. So we end up at -3, -2. Now we have to look for relationships. So what's the deal going on with -3, -2 and the original ordered pair? If we rotate it 180 degrees, it's still the old x, but it's the opposite of the old x. So the new x is the opposite of the old x. The new x is the opposite of the old x. That's how you read that, right? Well, what's the new y? The new y is the opposite of the old y. Well, that's funny, right? Don't you find that funny? You know, not like a knock-knock joke funny, but still like, huh, that's interesting. That's funny. Now, what's going to happen after a 270-degree rotation? And again, like I've said before, 270 degrees is 180 plus 90. Check it out. Vertical angles, what? Okay, review, done. So now, what happens after a 270-degree rotation? We end up here. Now, where in the world is here? We have +2 in the x, -3 in the y. +2 in the x, -3 in the y. And how does that relate to the old ordered pair? Okay, so we have our old ordered pair and the new ordered pair, right? So it looks like our new x is the old y. Funny. The new x is the old y. Funny. The new x is the old y. And what's the new y? The new y is the opposite of the old x. The new y is the opposite of the old x. So the new y is the opposite of the old x. And this is some interesting stuff happening here, right? You should be saying, whoa, Mr. Katz, that's pretty awesome. And I would totally agree with you. Now, what would happen if we finished this? What would happen if we finished turning it all the way around? what would be the degree measure of that, first of all? And then you should say, well, it's all the way around. It's 360 degrees. True. So it's 360 degrees, but where would we be? We'd be right back to where we started at 3, 2. And guess what we have? The new, after a 360 degree rotation, the new x is the old x, and the new y is the old y, so everything remains the same. The new x is the old x, the new y is the old y. And that is a handy-dandy chart to remember. And that's how rotations work. They go counterclockwise, and as we go 90 by right angles, if we are rotating by right angles, this is how it progresses. After the first rotation of 90 degrees, the new x is the opposite of the old y. The new y is the old x, and so on and so forth. And you can pick up some patterns to help you recognize what's going on. But this is super, super helpful to memorize that. So let me put that word, memorize. And you'll see that. You'll see it again through this lesson. Anywho, that's like the intro so you understand rotations. And now what we're going to do is talk about some vocabulary. Woohoo! So now we're going to do some vocabulary for rotations, make sure we understand some stuff. Pause as you need to. Vocabulary about rotations. Rotations happen around some given point, and we call that point the center of rotation. Okay, so we're rotating around. That point is called the center of rotation. And rotations have an angle of rotation, and that angle of rotation is measured in degrees going counterclockwise around the center of rotation. Exactly what we had just done in the previous example. And rotations are rigid motions. That means there's no change in the size or the shape of the pre-image to the image. Okay, so it's a rigid motion, no change in the size or shape from the pre-image to the image. And that's your vocabulary. Make sure, if you need to pause and copy that down, do so. So the first thing we're going to do is focus on reading rotations. Okay, so how do we read rotations? What's the format for this? Look at this garbage. This is so much fun. Look at this funky things we have to memorize. Remember how in reflections we had a capital R? Well, for rotations we got a lowercase r. And so you look at this format and how we read that. We read the rotation of lowercase r, the rotation of a point or a shape or something, right? We're rotating the thing, and we're going to rotate it 90 degrees around 0, or around some center of rotation. Okay, so that's the format. We read this. The rotation of xy 90 degrees around 0. That's how that's read. In this case, the rotation, small r, the rotation of xy 270 degrees around 0. Okay, so what do we do with that? We have that, remember I told you to memorize a thing? Well, I wasn't kidding. It's actually a thing, right? So this stuff you have to memorize. It's this key concept. All 4 basic 90-degree rotations. We have to know how that works in the coordinate plane. Okay, so it's what we've already covered. The rotation of xy, 90 degrees around 0, where does it end up with? The new x is the opposite of the old y. The new y is the old x, etc., etc. So we have to know this stuff. Pause, memorize, understand, and move forward. Okay? Okay. So let's have some fun, shall we? Yay, Mr. Katz, I love fun. Now what we're going to do is draw some pictures. Yay, just like kindergarten, we're going to draw pictures. First things first, I want you to pay attention to the directions. Look at how the directions are going to be read. What is the image of blah, 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 blah? And we have to know how to read that. The small r is rotation. So what is the image of the rotation of triangle LOB 100 degrees around C, around point C? Okay, so that's how that's read. Rotate triangle LOB 100 degrees around C. And that's what we're going to do. And we have to learn some stuff. Okay, there's a whole set of steps in order to perform this. So we have this triangle, and we need to rotate it 100 degrees around the point C. So let me give you two helpful hints. We need a protractor and a compass. Okay, so that's the first thing. We need our precision tool. Protractor and a compass. Make sure you know that. We need our precision tool. And then the next thing we're going to do is make some rays. Make rays and copy segments. That's what we're going to do. Woohoo! So it's nice and easy. We're going to make rays and copy segments. So what's this guy talking about, make rays and copy segments? Well, let's look, shall we? If we're going to rotate this whole triangle 100 degrees around C, well, we better know what 100 degrees is, right? So the first thing I'm going to do is take the distance or make a segment from C to O, okay? And I have this distance now from C to O. And now what we're going to do is measure with our protractor 100 degrees. So how does that work? How are we going to measure 100 degrees? Well, let's turn our paper to make life easy, because as we read the protractor, the center of it, remember we're going counterclockwise. Counterclockwise. Woo! Counterclockwise. So the center is going to be at the point C, because that's our center of rotation. Funny the word center. Now we're going to measure 100 degrees on the compass. Here's 90, here's 105, therefore 100's right there. So that would be 100 degrees. So what we're going to do is make a ray, okay? So we're going to make a ray from the center C through that 100 degree mark, okay? So we made a ray. So what we're going to do, we made rays, now we're going to copy a segment. Okay, so to copy the segment, remember how to do that. We have our center on the center, right? The center on the center of rotation. And then we're going to measure using our protractor. We're going to measure the segment from C to O, and there it is. So now we have our segment measure from C to O. We've measured it, and now we're going to copy that segment onto the new ray. Okay, so we now have, what is there? We now have a new point O, or O prime. So we have the image of O. Okay, so that's how that works. So what do we do now? We do the same thing with L. Okay, so the exact same process, we're just going to repeat it. Okay, so we have the same process, we're going to repeat it. From C to L, we make a segment. We're going to measure the segment 100 degrees. Okay, so watch what's happening. The center on the center, we measure 100 degrees. And then we make a ray. So we make a ray. Right, remember how this works. Make rays. And now what we're going to do is copy the segment. So remember the segment we just made? We just made CL. So we're going to copy that segment. We measure it. We adjust our radius to make sure we find the measurement, which is that. And now we're going to put that onto our new ray. Ta-da! Now we have our new L, or L prime. Okay? So we have our new L, or L prime. And we do the same thing with B. Okay? Okay. Pretty cool? Pretty cool. So let's go. Boom, bam. Now, measure 100 degrees. See how this goes? Or I'm going to do it fast again for the next one, too. So now we have B, are lined up with flush. Remember that flush, that word flush? There's my 100 degree measure. I'm going to make a ray. I'm going to make a ray. Yes, you heard that correctly. Now I'm going to measure my segment so I can copy the segment. And I adjust my radius. It is that big. And now I have B prime. Okay, so now I have my new B, my B prime. So I have all of my new points. So what I do is basically make my triangle. So I connect my, my segments from B to O, from B to B prime to O prime, B prime to L prime, and then L prime to O prime. And ta-da! Guess what we have done? We have taken our original triangle and rotated it 100 degrees around point C. Okay? Okay. So let's do that again, shall we? Yes, but this time with a different question. Okay? So with this different question now, we're gonna rotate the image, or we're gonna rotate the triangle LOB 50 degrees about B. So we're gonna rotate this 50 degrees about B. Okay, well that's interesting. So it's going to be the same type of thing. B, however, is our new center of rotation. So how can we measure 50 degrees about B, especially if we're going to go counterclockwise? Okay, so how does that work? Well, let's use the given segments. We don't need to make the original line segments. It's the same thing. All I have to do is turn my paper, right? If I just turn my paper, B is my center of rotation. Okay, B is my center of rotation, and I'm going to measure 50 degrees. Well, 50 degrees is right here, because I read my protractor. I make my ray, right there. Okay, so it's the same thing. Make rays and measure segments. So now I just measure the segment OB. Okay, so there's my segment there. Boom, right there. I now have O prime. Okay, so here's my O prime. And we do the same thing with L. Okay, so very similarly, I just turn my paper. LB is like my 0-degree angle now. And so I measure 50 degrees right there. Make my ray, because we make it ray around here. And then we measure our segment that was there. So we can copy segments. And boom, right? All set. Ta-da! There's my new L. So my L prime. Okay, so we have everything set up right there. Boom, bam. All we're going to do now is connect our segments here, and we now see the triangle rotated around B. Okay? And this is, hopefully you see that this is not a reflection. Okay, this is a rotation. This is totally not a reflection, it's a rotation. So you have to see the difference between rotation and reflection. Okay? Okay. So let's see how this works in like mathy speak. So now let's talk about rotations on the coordinate plane. And we'll hopefully remember how this works. So check this out. PQRS has vertices here, 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 and here. What is the graph of the rotation of PQRS 90 degrees around 0, around the origin? Okay, so we're going to rotate these ordered pairs 90 degrees. How do we do that? Well, remember our cheat sheet. What's a 90-degree rotation? A 90-degree rotation is when we have the opposite of y and the original x, right? The new x is the opposite of the old y, and the new y is the old x. So we're all set. So it's so easy, right? What's the graph of those? Well, p prime is now opposite of y and the old x. That's p prime. Q prime is now the opposite of y and the old x. R prime, very similarly, the opposite of y and the old x. And then S prime, the opposite of the old y and x. Ta-da! And that would be the graph of PQRS. All you got to do is throw that on a coordinate plane, and we're all set. Okay? And so now what we have here, very similarly, what's the rotation of this graph? 270 degrees around 0. Very similarly, we're going to do the same thing. What's the 270-degree rotation? 270-degree rotation is the new x is the old y. The new y is the opposite of the old x. And we have to remember that. Okay, so what's going to happen? That means this right here, f, the new f prime, will be at 2, 3. Okay, so the new f, 2, 3. The new g prime, was that -3, -1? Well, the new is going to be -1, the old y, and the opposite of the old x. So that's our new g, -1, +3. Okay, the new h prime, same thing. The new coordinate is the old y, -1. The new y coordinate is the opposite of the old x, -1, -1. Funny, that didn't even move. Excuse me, -1, +1. It did move. And then our new I. It's the same thing. So the new coordinate is the y, and then the old x, opposite of 0 is 0. We got to know that. And so we have 1, 0. This is our new polygon. Ta-da! So we've just rotated it around the origin. So that's how that works. And again, you want to memorize those things. Now I'm going to show you one last thing. We're going to call it a day. One last thing. Check this out. This question on the quick quiz. We have an octagon, a regular octagon, which means all angles are the same. All angles are the same. Like all these angles are there's it's all composed of congruent triangles. Okay? And so how are we going to do this? Well, how many triangles are there? We've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 triangles. And if the center of everything is 360 degrees, well, what would be the measure of each of these angles? So, funny how that works. If we divide 360 by 8, we get 45 degrees. So remember, we have 8 triangles. 1, 2, 3, 4, 5, 6, 7, 8. 360 is the full circle. That means each angle right in here is going to be 45 degrees. So what is the image of point B after a 225-degree rotation? Well, let's count it up. 45 is the first rotation, right? So from B to here, 45 degrees. And then we do it again, we're now at 90 degrees. And we do it again, we're now at 135 degrees. We do it again, we're now at 180 degrees. We do it again, we're now at, guess what? 225 degrees. So isn't that funny? We got to put all those things together, and then we'll find out, well, what's the image of point B after that rotation? It's now at point E. So the image is point E. Isn't that fun? Yay, math. So yay, that's fun. And that's enough for today. That's it for rotations. That's it for the units. It's all rigid motion. We now know it all. So the rest is practice, practice. Get it all down, and I'm out of here.